So in this problem, you are supposed to take a 4-bit synchronous counter with parallel load and a minimum number of additional gates as needed to construct a counter that counts from 0011 through 1010. So you can assume that the counter works. And so what that means is that it's a regular counter, and on each clock cycle, its count will go up by 1. So if it starts at 6, next clock cycle will be 7, and next will be 8, and next will be 9, and so forth. It's a 4-bit counter, so when it gets to 15, it'll go back to 0. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 0, 1, 2, 3, 4, 5, 6, 7. But this, it may not start, well, this one starts at 0011 and goes through 1010. So you don't need to know this, but 0011, that's the 1's place, 2's, 4's, 8's. This is 1 plus 2. That is equal to 3. 1010, that's the 1, 2, 4, 8. This is 2 plus 8, so that's equal to 10. So this counts from 3 to 10. So in other words, we want it to start at 3 and count up to 10. So that's what your job is. But I'm not going to do this exact one, but I'll do one that's similar. So let's say that we need to have a counter that counts from 5 to 14. Okay, so let's say that's what our job is. So our counter will start at 5, and so that is the binary number 0101, and it'll go up to 14. And so if this is the 8's, the 4's, the 2's, and the 1's, 14 is 8 plus 6, that's 8 plus 4 plus 2, so that's 1110. So it's supposed to start here and count up to here. And again, we can assume that the counter works, that it will, on each clock cycle, go up by 1. It also has a load, so what the load does is when the load equals 0, it counts, or it increments the count. When load equals 1, it loads the values. So if we want it to start at 0101, so this is Q0, Q1, Q2, Q3. Notice these are D's, so these are D, indicate D flip-flops is what the counter is made of. So we need D0 to load to 1. We need Q1 to load to 0. We need D2 to be 1, and we need D3 to be 0. So this will load the value, I put that accidentally in load, this will load 0101 whenever load is equal to 1. We also need to have this enabled, and I don't think there's any reason we ever have to have it not enabled. So I'll just connect a 1 to the enable, and I'll connect a clock here to the clock. But I am going to connect something different to the load. So what I'm going to connect to the load is I want it to, anytime it gets to 1110, I want it to start over. So when it gets to 1110, I want it to load.
Oh. And I'm sure.
So we want it, when it gets to 1110, or when it gets to Q3 equals 1, Q2 equals 1, Q1 equals 1, and Q0 equals 0, we want it to load. We want it to load at that time. So what we can do is we can take the outputs of Q3, Q2, and Q1 and them together and connect those to the load. Now, we don't actually have to do anything with the Q0. We could, but it doesn't really matter because it's not like it's ever going to have the value of 1111, because once it gets to 1110, it's going to roll over. And so you don't need to check to see that Q0 is also 0. It wouldn't hurt, it doesn't hurt anything, so if you wanted to put, a not Q0 in there, you could, but that's just a waste of, just a waste because you don't need it. So you can take that out. And this is a parallel load that counts from 0, it counts from 0101 through 1110. So that's how you would do that one. And then it asks to repeat for another count. So let's try another one. Let's do a count from this one. It does not. These don't roll. These don't go back. These don't go back through 0. They're just going up. So let's count from 0, 1, 1, 1 to 1, 0, 1, 1. So it's going to start with 0, 1, 1, 1. And then it'll go to 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. So that's the count. And when it gets here, we want it to go back to here. So let's see. We would load 1, 0. We would load 0, 1, 1, 1, and we're trying to detect when we get here. So what's going to be true when we get here? Well, when we get here, this is going to be the first time that we have so there's two ways we could look at it. From starting from here, it's the first time that Q2, Q1, Q0 are 0, 1, 1. It's also the first time that Q3, Q2, let's see, Q3, Q2, and Q0 are 1, 0, and 1. Do I need this Q2? No. What I do need is I need Q1 to be 1. So it's the first time after 0, 1, 1, 1 that Q3 is 1 and Q1 and Q0 are 0. So could I check to see if also Q2 is 0? I could check for that, but I don't need to, because there is here, if I look at the values of Q3, Q2, Q1, and Q0, and I'm looking just at these, when I start, they're 1, 0, 0, so they're not that. Here, they're 1, 0, 1, not that. The next one, they're 1, 1, 0, not that. And then we get to 1, 1, 1, and it is that. So those are the ones I can check for. So when, or I could check for Q2, Q1, and Q0. So in that case, I would need to check the last the last three digits. And the reason I would need to check Q2 in that case is because when we start, we have the last three digits are 111. So just checking to see when the last two digits become 11 is not going to be enough, because it would never go anywhere, because when you start, they're 111. They're 1 and 1. So I'm going to check this last one, because that will just be a NOT gate. So I'll go Q3, Q1, and Q0, and I'll AND those and put those into the load. I'll have an enable, and I'll have a clock.